We have developed planes that fly at supersonic speeds. We've walked on the moon, created a reusable space shuttle, an orbiting laboratory, and now we're developing a spacecraft to take us to Mars or beyond. NASA has had so many great accomplishments, but none of that would have been possible, nor will we reach our future goals without stringent ground testing. NASA Glenn Research Center has built many world-class ground test facilities at both Lewis Field and Plumberg Station. And as the chief of the Test Facility Management Branch, my team and I are charged with ensuring that the facilities at Lewis Field are ready to test. And we advocate for ways to improve them to keep up with the demands of the future. I'll share with you a few examples. At GRC, we have 3 facilities where we test aircraft components, scaled aircraft models, as well as scaled space launch vehicles to better understand how air moves through and around them. They are the 10 by 10 foot supersonic wind tunnel, the 8 by 6 foot transonic wind tunnel, and the 9 by 15 foot low speed wind tunnel. In the 8 by 6 foot transonic wind tunnel, we can achieve air speeds up to 1,300 miles per hour. And in the 10 by 10, 2,700 miles per hour. In both tunnels, we use large hydraulic jacks to push and pull on each of the tunnel walls to create the contour that's needed to achieve those air speeds. You'll see in a time-lapse video as nearly 1.5 inch thick stainless steel walls are forced to flex about 3 feet to meet those conditions. In the 9 by 15 foot tunnel, we achieve air speeds up to 175 miles per hour, and we simulate takeoff, approach, and landing conditions. And this tunnel remains in high demand for tests and reducing aircraft noise. But as airplanes get quieter, it's important that our tunnel get quieter too. So in our acoustic improvement project, scheduled for completion in late 2018, we are refurbishing multiple sections of the wind tunnel circuit, including making smoother walls and turns, lengthening the test section. Above our atmosphere, the challenges continue. The condition of weightlessness that one would experience in space can only be achieved here on Earth by being in a state of free fall. So to mimic this condition, in the 1960s, GRC built the world's tallest low-gravity drop tower, called the Zero Gravity Research Facility, or ZeroG for short. Now, ZeroG is a 28-foot diameter hole in the ground that extends about 500 feet deep. There, we load experiments into a drop vehicle, place a cap over the chamber, and remove the air. When the drop vehicle free falls, the experiment inside will experience weightlessness for 1, 2, 3, 4, 5 seconds before landing in a bed of styrofoam pellets. We can conduct 2 drops per day, and we average about 100 drops per year. But in those precious 5 seconds per drop, we have conducted fundamental studies in many areas, including material science, fluid physics, and combustion, just to name a few. Recently, at GRC, we began investigating ways to extend the duration of weightlessness within the same footprint of ZeroG. We call one concept an electromagnetic drop tower. In this concept, experiments are loaded into a vehicle at ground level, then slowly lowered along the rails of a vertical maglev train to the bottom of the chamber, and then, like an amusement park ride, accelerate up to the top and back down again, effectively providing 10 seconds of weightlessness. The additional 5 seconds of weightlessness can open the door to additional fields of study, such as plant growth, fire safety, and even the human cellular response to weightlessness. In addition to weightlessness, the extremely cold temperatures and the absence of air molecules are the other differences between Earth and space that make realistic ground testing essential for our success. At GRC, we have about 24 chambers in which we simulate this vacuum of space to test everything from small components to large spacecraft assemblies. When fully evacuated, the environment inside of these metal containers is very similar to that of low Earth orbit. The primary use for most of our chambers at Lewis Field is to test electric propulsion devices. Now, these devices are also known as ion engines or thrusters, are highly efficient engines that can use gas as a propellant, but they only operate in space. At GRC, we actually developed the first ion engine. It was actually Dr. Harold Kaufman who developed this engine here. And our largest facilities at Lewis Field, Vacuum Facility 5 and 6, were made in the 1960s to support the development of ion engine technology. Now, Vacuum Facility 5, or VF5 as we call it, is a workhorse facility for electric propulsion because of its unique ability to maintain a highly pure vacuum, even when gas from a thruster is being added to the chamber. The rate at which we evacuate air or gas from a chamber is what we call the pumping speed. And VF5 has the highest theoretical pumping speed in the world at 3.5 million liters per second. At 3.5 million liters per second, you could evacuate all of the air out of Cleveland's Terminal Tower in less than 1 minute. Vacuum Facility 6 is our largest chamber at Lewis Field, and it's equipped with an interior shroud that can get down to negative 330 degrees Fahrenheit to simulate the cold environment of space. Now, with the installation of the interior shroud, VF6 has been the go-to facility for clean power testing for many years. But in 2016, as we began to use VF6 again for electric propulsion testing, we covered the interior shroud with thin carbon sheeting in order to protect it from the thruster's exhaust. And since that time, we have once again successfully conducted electric propulsion testing there. Now, we are investigating ways to improve the pumping capacity of VF6 to be equivalent to or even surpass that of VF5, so that we may test higher power, higher thrust engines there, because these are the types of engines that we'll need to power our spacecraft for our missions to Mars and beyond. Improvements and sustained investments in our facilities have allowed GRC to offer unique testing environments to NASA, other government agencies, academia, as well as our industry partners. As NASA continues to push the boundaries of space exploration in the envelope of aeronautic advancements, GRC will be on the forefront of specialized testing and technology development by conducting amazing research in amazing facilities for the benefit of all. Thank you.